All right, so let's come back to this. So f of x minus g of x, well, that's simple. That's just taking my f of x, which is x squared minus 3x. Now, be careful. I'm minusing all of this, 2x minus 1. So I put that in a bracket because I want to make sure that I'm actually minusing the whole thing. So what that ends up with is this, x squared minus 3x minus 2x plus 1, which simplifies to x squared minus 5x plus 1. So when we did the subtraction, right, to nobody's surprise, we got another quadratic looking function, which still opened up. I don't know if you remember that from the second graph. When we did the second graph, it opened up because it was x squared minus 5x plus 1. That's exactly what it was. Okay? And then when we did it the other way, right? So no, the other way would mean that I'm taking the 2x minus 1 and I'm subtracting the x squared minus 3x, right? I put that in brackets as well. So that would be equal to 2x minus 1 minus x squared. So you're beginning to realize, no, that's why this thing was turned upside down. And of course, plus 3x. Okay? And when I simplify that, I get minus x squared. And then what is this now? 2x plus 5x and minus 1. Right? So this graph here was it was the last one that we just drew. So every time we're subtracting functions, we just put brackets around f of x. Absolutely. All right. Right? That makes sure that you subtract the entire function. Okay? Not just the first part, because sometimes students will just put minus 2x minus 1, and then they don't realize that the minus should apply to both things that are inside that bracket. Okay, so there you go. That's what this function looks like. This function absolutely does turn upside down because it has a negative a, right? And that's why our last function had a negative a. So even though we didn't have the actual equations, we could have come up with a reasonable sketch of the sum and the difference by just simply using a superpositioning principle that we were using, right? Having the actual equations would be nice, but we don't have to have the equations for us to know what the resulting points are on the graph. Okay, so hopefully that is fairly clear. And yes, my recording is going. So the recording of what we did on the Jamboard is not there. To be honest with you, that didn't work out. But what I'm doing from this point on is. All right. So let's move on. Let's talk now about domain, right? What happens when you combine functions? What happens to their combined domain? Well, think about the fact that if you are trying to add together corresponding x values, then those x's both have to be in the domain, right? If you have x's in one function, but those x's are not in the other function, you cannot add those two values together. The x's must therefore be common to both. So one of the things that you need to recognize is what is the common domain between two functions that have been either added together or subtracted from each other. So what I've done is I've done a series of questions here to show you what I find is the easiest way for you to figure that out. So let's say you were told that one function had this domain, right? I'm underlining it here, that it only goes from -5 to 9. That's as far as this function goes, right? So the function for the first, the domain for the first function only extends from -5 to 9. Then you're told, I want you to add that to another function, and that second function goes from -8 to 12. So what should you expect to be the domain of the resulting function? Well, it's only where they have common ground. And what I find is the easiest way for me to figure that out is to use a number line. So what I'm going to do is I'm going to put this on the number line right now. The -5 to 9. Now remember that because -5 is included and 9 is included, I'm going to put a solid circle on both ends of that. So I'm going to go from -5, right, all the way to 9. I'm going to put a line that joins those two together, right? So that's one domain on the number line. Then I'm going to use, for domain 2, I'm going to use a different color for that. For domain 2, I'm going to go from -8 to 12. Well, -8 is over here. And again, it's less than or greater than or equal to. So -8 up to 12, right? So all of that is included. So remember, I'm adding these two things together. So when I look at this number line that goes from minus 5 to 9 on top and from minus 8 to 12 on the bottom, the question is, where do they have common, or do they share common ground? Where would I consider to be the shared domain between both of these two domains? What do you say, folks? What do they have in common? From where to where do they both share common ground or common domain? Does anybody have an answer for that? Right? Where do they overlap is really what I'm saying. Where do those lines, where does my red line and my from minus 5 to 9? Absolutely. So my answer could look like this. The domain of the sum would go from minus 5 to 9. In fact, it's the same domain as domain 1, right? So what is happening is that even though the second function goes over a wider domain, I can only find x values in common between them between minus 5 and 9. That's the only place they're going to have common x values that I can link together. Okay? So thank you very much, Ryan. Thank you. Is that how we write it? Yeah, you can write, remember, you can write using the inequality signs or you can write using the brackets. Either one, I'm fine with it. Okay? Let's try this again. What if my first domain was from minus 1 to 6, and the domain of the other functions, remember, we're dealing with two functions now that have separate domains, and we're combining them, and we want to see what the combined domain is. So one goes from minus 1 to 6, again, greater than or equal to, so I put a solid circle there. So minus 1 to 6, right? In between those 2 points is where one domain extends. The other one goes from 2 to 8. So I'll use a different color for that. Right? I'll use, I don't know, green. Again, there are solid circles here from 2 to 8. Okay? So look at those two. What is their common ground? I think using a number line makes it very, very obvious. Look at Natasha's answer. Natasha has already concluded, and Chrisania was there from before that, and Brendan and Hussein agreed with that the common ground where they will both have x's that are the same only goes from 2 to 6. So it's part of one domain and part of another domain that would be the common domain between them. So here we go. It goes from 2 to 6. That's where they share x's. That's where we can combine them. We can't combine them if there's no x in one to match up with an x in the other. We just can't combine them by addition. In fact, we're going to talk about how this works with composition in a minute. But for right now, we're just talking about adding and subtracting the functions. To get the common domain, we have to look for where it overlaps. Where do they have common ground? So wait, so is it as easy as this or will it get harder? I don't think anything in math is hard, Brenda. Come on. I don't know what you're talking about. Everything in math is so easy. Let's get to the next one. So, okay, this one goes from 2 to 12. So I'm going to go from here again, right? I'll use red for the first one. So from 2 to 12 right there. And then one goes from minus 8 to 1. So minus 8 is over here. I'll use a different color. Minus 8 to 1. Okay, so what's the story here? From 2 to 12 and from minus 8 to 1. Natasha says, oh, I'm not sure what she's saying there. They don't overlap, Natasha says. Chrisania says from 2 to 1. All right, so I'm not sure who is right and who is wrong because you can't both be right, right? Does the function not exist? Okay, so the sum of the function does not exist, right? These two functions cannot be added together, is what we're saying, right? So we're saying that the result of this is the empty set. There is no overlap between these two. And that can happen. You cannot add two functions together if they'd have no x's in common. If one goes from 2 to 12 and one goes from minus 8 to 1, then there is no overlap. You cannot add these functions. You cannot subtract them. You cannot add them, right? So I try to give you an idea. And again, don't use the number lines if you don't need to, if you don't want to. I'm not telling anybody that this is what you have to do. Number lines don't work for you, then don't use them. Okay? That's fine with me. All right. So hopefully everybody, so we gave you 3 different cases here. Let me just go back a bit. One of the cases was where having another function did not increase the domain of what you started off with. The last question. Let me see. I'm just taking a note. If you said to get the common domain, you said yes, yes. I'm saying to get domain. Yeah. Sorry, Ryan. How would we figure out without the number line? I would say draw the number line. What's the problem with drawing the number line? Right. I'm saying the number line is a visual aid for you to get the answer. So why not draw it? I mean, everybody knows how to draw a number line. So draw the number line. I do it sometimes. Draw the number line, especially if it's more than two conditions. What if I'm adding three functions together? Then I think the number line really helps. You have to see where three sets of conditions have to be met, draw the number line, and then you look for where there is common ground between the three of them, right? But you don't have to. I'm not saying you have to, and I would say that it's just I just think it's a good idea. Is my position. So the first one was where it doesn't change the fact that from -5 to 9, if you put that with -8 to 12, it's still -5 to 9. That was one possibility. There was a possibility where it would be a part of one and a part of the other. And then there's a possibility where there is no overlap at all. That's just the way that goes, right? So those are three different distinct ways in which two functions you could attempt to add them. In some cases, you can't do it, as I said, because you just don't have any areas of overlap. What if I gave you a picture, right? What if I said that the red line and the blue line represent graphs of functions, right? And I said, where can you sum these functions? What's the domain of the sum of these two functions? What would your answer be just looking at the picture? What's the domain of the sum of the red line and the blue line? Can you answer that question from the picture? Not a number line this time, but kind of similar. What's your answer now? Right? So those two functions have their first, the domain of one goes from -1 to 2. The domain of the other goes from 0 to, I think it's 3, to 3. So from 0 to 2, there you go. The domain goes from 0 to 2. All right. Thank you, Quinn. Thank you, Brendan. Thank you, Natasha. All right. Everybody okay with that? Makes perfect sense. We're going to move on now. The one that's more challenging is this one. So I'm going to sort of take my time with this a little bit more. We're not looking at adding and subtracting for this. Adding and subtracting is hopefully relatively straightforward, but getting the domain for composite functions is a little bit more tricky. So let's spend some time going through this. So I'm going to be composing two functions. One is a log function, base 3 log of x, and the other one is a square root function, square root of x minus 2. And I'm going to be asking for the domain of the f of the g of x, fog x, and by the way, these two things mean exactly the same thing, so I put a little wing bracket here. I just want everybody to remember that either of these could be used for when you are composing functions. So I could either say f of g of x, or I could f little circle g x. If you see that on a test, like maybe tomorrow, right? Don't think it's anything different from what we've talked about. It's the same composition that we've talked about. F circle G X means f of G of X. So what we're about to do, so that's what this is. This is not two different questions, right? This is one question, just stated two different ways. All right. So really, this is f of G of X. It means we're putting the G function inside of the X function. So really what it looks like is this. It's the log base 3 of the square root of x minus 2, right? That's what we're doing. We're putting the g function, which is the square root of x minus 2, into the f function. All right, want to make sure everybody's with me so far, that this makes perfect sense, all right? Shiabon, how about you? Roma says, yeah. Shiabon, how about you? Are you good with that? I'm not using the wheel. I'm just calling people at random from just that's all I'm doing here. Okay, perfect. All right. Now, what would be the domain of the composite function is what we're trying to figure out here. Let's just think this through. We know that when we're taking square roots, well, what do we know about taking square roots, right? What is the restriction if we're taking a square root? Square root has its own restriction. Logs have their own restrictions. Let's start with the square root. What So Hussein says no negative numbers. Absolutely. Right? The thing under the square root sign has to be positive. So here's the first condition that we have to set. We have to start by saying that the thing under the square root sign, the x minus 2, must be greater than or equal to 0. It's okay for it to be 0. Can we accept that? Right? You can take the square root of 0. That's not a problem. That's good. Can we accept that that's good? Make sense? Are we good with that? Does that make sense, everybody? Perfect. Okay, Alexa says yes, and Roma says yes, and so does Sindhuja. So one condition that has to be met for this domain is that x must be greater than 2, which means, sorry, x minus 2 must be greater than 0, which means that x must be greater than or equal to 2. Okay, that's the first condition. That's the inside condition we have to meet. We have to meet that. So this part of the function right here, right, the condition for the inside function is that x must be greater than 2. That's the first thing. The second condition that has to be met is that we have to take the log of this result. No, it means that this thing here, this x minus 2 itself must also be greater than 0, not greater than or equal to. Let me just make sure we're clear on that. It must be greater than 0 because you cannot take the log of 0. Square root of x minus 2 cannot be 0 for log. Perfect. Right? It can not only can Kelvin, not only can it not be 0, it can also be negative. It has to be positive. You cannot take the log of a negative number. You cannot take the log of 0. You can't take the log of a negative number. So it means that we also, after you satisfy the condition that x has to be greater than or equal to 2, so that's one condition you have to satisfy. But also, when you take the log of this red circle, right, whatever is in that red circle must itself be greater than, but not even equal to 0. It must be just greater than 0. So how do we solve this inside condition? Well, don't know if you know this, but you can square the two sides of this, right? So if I square this and I square this, squaring the left-hand side gives me x minus 2 greater than 0, and therefore x must be greater than 2, greater than 2. Not greater than or equal to, by the way. Not greater than or equal to, but it must be greater than 0. Greater than 2. So this represents the actual domain of the function, right? We've satisfied both. We've satisfied the inside part that says x has to be greater than or equal to 2, but a further restriction on that was that x must be greater than 2 itself. So we have to use a more restrictive condition. It's just like putting them on a number line, by the way, very similar kind of thing. So we're taking the first restriction, which is x has to be greater than or equal to 2, and adding to that x must also be greater than 2, and this last thing here represents the domain of this. If I were to draw this function, the f of the g of x function, you notice that it only goes from where x is greater than 2. It goes from 2, positive 2 onwards. Okay? All right. So I know that's a little bit more work than the first one, but I thought I'd make sure to go over that with you. So that takes care of the first one. Is it the same if we go the other way? Well, let's find out. The g of the f of x, remember, and I said this to you when we were doing compositions of functions earlier on, f of g of x and g of f of x are not the same thing. Oh, by the way, speaking of which, not that this has anything to do with the bonus, there's going to be a bonus question on the test tomorrow. And a bonus simply means what you know a bonus means. It means that get it right, it could actually add to your overall score, but it's not going to be what the test is out of. So let's say, for instance, I'll just give you an example. Let's say that the test was out of 10, and you also did the bonus question and got it right. You could potentially, if you got all the other questions right, get, let's say, 12 out of 10, because I gave 2 points to the bonus, which you mean you got 120%. So you could potentially get over 120%. Sorry, over 100% on this test. I won't even tell you which one is a bonus question, by the way. You attempt them all, and if you get this one right, it could really sort of help your mark out a bit because you're getting more than 100% if everything else, of course, is right. Okay? All right, 40%. Oh, it is a 40%. Yeah, there you go. You're doing a little math there. That's good for you. Okay, let's get back to this question. So now, what we're looking at is the opposite composition. So it's the square root of the log of x, log base 3, is the square root of, think about what g of f of x is. I'm putting the f function, which is the log base 3 of x, into the g function. So log base 3 of x minus 2, right? That's the function that we're dealing with. Okay, well, let's see how you do with it first. Is it going to be super hard? It is going to be challenging. I'm not going to lie. All right? It is going to be challenging. And again, you're not going to lose anything by not doing it because I'm not counting it out of the total in the test. Just remember that. All right. Okay, here we go. Let's get back to this. So what we're saying now is that there's a square root and there is also the log base 3 of x minus 2. Let's take the inside of this here. Right. And by the way, everybody, will we get part marks for attempt? We'll get to all of that. I have a question in mind already, but we'll see. We'll get to that. And let's get back to this. So hopefully everybody agrees with what I've done for the g of the f of x, right? The g function, which is the square root of x minus 2, right, is going in. The f function is going into the g function. I said that wrong. So the f function is the log base 3 of x. So wherever I have x in the other function, I'm putting that in its place. So here's what we have. So we know that the thing under the square root sign must be greater than 0, greater than or equal to 0. We know that, right? So, there are two things that we know. We know that this x here must be greater than 0. Right? Because I'm taking the log base 3 of x. Can we all accept that? Right? If under the square root sign, there is a log base 3 of x, then it means that the x there must be greater than, not equal to either. It has to be greater than 0. That's the first thing we have to say. Everybody okay with me? Everybody okay with that so far? That's the first condition we have to satisfy. Second condition is that this thing under the square root sign, the log base 3 of x minus 2 must also be greater than or equal to 0. It can be equal to 0. That's fine because it's a square root, right? So remember that. It can be equal to 0. Square root of 0 is 0. So we're good there. Can't be less than 0, but it can be greater than or equal to 0. So we need to solve this inequality, all right? What would the next step be in solving this inequality? What do you think, folks? What's the next step in solving this inequality? Right? We've done inequalities. We've added 2 to both sides. Okay. So the log base 3 of x is greater than or equal to 2. Okay. Can you explain why the x has to be greater than 0 again? Sure, Ryan. Okay, let's go back up and look at what this says. Inside of this square root, Ryan, do you see where it says the log base 3 of x? You see that? That's part of the question, right, Ryan? Okay. I know you know this, that you cannot take the log of anything which is less than 0. A log has to be taken of a positive number. So if I'm taking the log base 3 of x, it means that my x must be positive. Okay? And that's what x greater than 0 means. Okay. Thanks, Ryan. And I always thank people for asking questions. I want you to do that. Okay, hang on. Well, you're getting Brendan. Yeah, hang on. So my next step is to do what? Right? And I see some people have jumped ahead of me already. Look at you people. Look at you. Just can't wait. So of course, putting this in exponential form, yes, you know this. Putting this in exponential form is that x must be greater than or equal to 3 to the power of 2. Okay? And therefore, x must be greater than or equal to 9. So look at the two conditions. X must be greater than 0, but x must be greater than or equal to 9. If you don't want to use number lines, fine, right? But what is the final domain of all of this? Some of you already come up with answers for this, by the way. Brendan certainly has an answer. And Chrisania looks like she has an answer as well. Yes, it is x must be greater than or equal to 9. You can satisfy, by satisfying this condition here, you've already satisfied that condition. right? If you're greater than or equal to 9, you're already greater than 0. That's, you don't have to worry about that condition anymore, right? So on a graph, if I were to draw the g of the f of the g of the f of x, I would find out that this domain, right, of the composite function would be where x is greater than 9. Okay? Does that make sense to everybody? Are we good to go? If I need to go over any of that again, I absolutely will. Shiobon says yes. What about everybody else? Right? Alexa says yes. Good. All right. So, will there be an assignment tomorrow? No, there is no assignment tomorrow. You have your summative graphs to turn in tomorrow. Okay, so there's no assignment tomorrow. I'm still working on the test that you have. I will make sure that it's fair, as I've always done that. It's only going to cover the stuff that we've actually covered here in class, right? So we've covered the composition stuff extensively. So the test tomorrow. Yes, Ryan. Yes, yes. Right. And so we've done the stuff on composition, so you should have no issues with dealing with any question on composition. And we've also done addition and subtraction, right? And let me just remind you that the summative graph needs to be turned in tomorrow. I'm not going to chase anybody down. It's going to be 35. It's going to be part of your assignment weighting. So 35%. You don't turn it in and get 0 for that. That could easily be a disaster for you. So I'm not going to chase you down, because at this point, I would think that you should understand the importance of getting all of this done.